All right, so this is our fourth chapter on probability, and this is the last one that really is focused on probability. We're going to be doing some in the next few chapters that use the word probability, but this is the last one where it really has different types of probability problems that we could look at. And this one's actually really short. The notes, as you can see, are only 1 page long. And this is the only chapter with any specific thing for the graphing calculator that we need to learn. So let's look at an example. We need to define a couple of terms, and then we'll see another example. So suppose a cereal manufacturer puts pictures of famous athletes on cards and boxes of cereal. The manufacturer announces that 20% of the boxes contain a picture of Stephen Curry, 30% a picture of Serena Williams, and the rest have a picture of Simone Biles. Let's assume you are only interested in finding a picture of Stephen Curry, and the pictures are distributed randomly. So this is what's called a Bernoulli trial. And so a Bernoulli trial is a trial where there are only 2 possible outcomes. And we have a success and a failure for each trial. Either you get Steph Curry or you don't. So obviously we have 3 options here: Steph Curry, Serena Williams, Simone Biles, but you're only interested in Steph Curry. So either you get him or you don't. So those are the 2 options. With Bernoulli trials, probability of success is the same for every trial. We denote that with a lowercase p. And so in this case, it's p equals 0.2 because 20% of the boxes have Steph Curry. And then trials are independent, meaning, again, independence meaning the same thing as meant before. Finding Curry in the first box does not change what might happen on the next box. So it's always, for any box that you pick, the probability of Steph Curry is 20%. So a couple other examples: tossing a coin. So it's either heads or it's not heads. Looking for defective products on the assembly line. It's either defective or it's not. Shooting free throws in a basketball game. So all these, so it's a binary outcome. It's either a success or a failure, and then the trials are independent. So picking cards, you have red and black cards, but if you're taking cards out of the deck, that would not be a Bernoulli trial because the trials are not independent in that case. So independence. 2 options, one being that you're interested in one and you're not interested in the other, or others, as in this case. We do have 3 options, but we're really just interested in the one. So we either get that one or we don't. All right. So now a binomial model is linked to a Bernoulli trial in that a binomial model can have several Bernoulli trials in a row. So say you're going to pick 5 of these cereal boxes. So a binomial model describes the number of successes in a specified number of trials. So we have N is the number of trials and P is the probability of success. So again, it's just a Bernoulli trial, but over many successive Bernoulli trials, not just one. All right, so in the cereal box example, what is the probability that you buy 10 boxes and find 3 Steph Currys? So again, let's talk about how we know when we could do this, when we would use this binomial model. So we saw in chapter 12, if you remember, the last example was M&Ms, and we had pink, purple, and teal M&Ms, and what's the probability? You ask 3 people, what's the probability that all of them choose pink, or something like that. So we had problems like that. In those problems in chapter 12, there's usually only one way to do that. So if you want 3 people to pick the pink M&M, let's say, then the first person has to choose pink, and the second person has to choose pink, and the third person has to choose pink. So there's only one way for that to happen. If we say, in this case, so let's say we have 10 boxes, 3, 4, 5, 6, 7, 8, 9, 10. How many ways could there be to get 3 Steph Currys. So it could be just the first 3. So maybe the first 3 have them, none of the rest do. Maybe the first, third, and fifth, maybe the first, third, and seventh, maybe this third, fifth, and 10th. There are many, many ways that you could have 3 Steph Currys out of 10 boxes. So that indicates it's a binomial because it's either Steph Curry or it's not. We have a fixed number of trials. So the 10 boxes would be the trials. The 3 Steph Currys would be the successes. And as we saw above, probability of success is 0.2. And so we can use the binomial model in the graphing calculator. And so I'll see if I can find a video that demonstrates on the calculator how to do that. But all you need to do is go to second vars, and it is, I believe it's 0. Maybe all the way down to 0 on mine, but whatever the binomial PDF is. So it may be different on different versions, but binomial PDF, you'll have to scroll down. So it's on the same menu as normal CDF that we did. And then you may get a menu, you may not. If you don't get the menu, then you'll have put the number of trials, the probability of success, and then X is the number of successes you want. So let's write that up here. X equals number of successes. So in this case, how many Steph Curry boxes do you want? And so the number of trials, so this would be binomial PDF. The number of trials is 10. The probability of success is 0.2, and then we want 3 of them. So NPX, number of trials, probability of success, and the number of successes that we want. And we put that in, and we get 0.201. And so you'll see these are, if you do a few of these are not ones that you could, it's not easy to guess what the probability should be. So you really have to trust that you're doing it correctly, you're setting this up correctly, because it's not one that you could easily guess. Like, you're not drawing the normal curve and shading part of it, and you can see that it's less than 50% or more than whatever it is. So the important part to remember about these, again, is we have a number of trials, a fixed number of trials. The trials are independent, and every trial is either a success or a failure. And when we get that, that is a binomial model. We use the binomial PDF. And I'll see if I can find a third-party video that it'll demonstrate on the calculator, although it's not super difficult. If you can do the normal CDF, you can do this one. All right, if you have any questions, feel free to email me.